Hello everyone. I welcome you all to your own YouTube channel Java Fun. So this is the third lecture in a fault tolerant microservices series. In the first lecture, we gone through the theoretical concepts of what exactly is a fault tolerance and what are the methods of achieving a fault tolerance in a microservices architecture. In the second lecture, we saw how to implement the circuit breaker pattern in a plain Java functionality. In this particular um, series, we're going to talk about how to integrate the Resilience 4J circuit breaker pattern inside microservices. So, what we're going to do today is I'm going to simulate interaction between two microservices, service A and service B, wherein from the UI, someone is calling service A is internally calling service B to return or get fetch some information from the database or from any other functionality, right? So what will happen if nodes of the service B starts to goes down for some reason, or if there are some delays? It will ripple effect it will be having is on the service A. Service A will also have a performance deterioration inside itself as well. So what we're going to demonstrate is that once the service B goes down, there should not be any effect on the normal processing of service A. That is what we call as circuit breaker patterns, right? So your service A has to be fault tolerant to the uh, anything which is going down in a microservices architecture thing, right? So this is what we're going to see today how to implement it. So what we'll do is our service A is, let's say, order service B is an inventory service. So from the UI, you order certain products and certain size. Then service A goes ahead and check in the inventory whether that product is available or not. If it is available, then you can place a order, right? So that is what we're going to demo today. So this is my project, plain simple Java project as of now. There is nothing in it. In my POM XML, I have put certain dependencies. So first of all, you have a Resilience 4J Spring Boot 2. Since we are using the Spring Boot for our microservices, to build our microservice, I need to use a Resilience 4J Spring Boot adapter inside it. Then you have an actuator. Actuator is for uh, checking the health of your service or the circuit breaker events of your emitted by your Resilience 4J library. So we're going to check whether the circuit breaker state is open or closed or half open. All those information will be available on the actuator. Web is nothing but for making HTTP requests. AOP because we're going to do some of the annotation processing, so that's why we would need AOP. And Lombok is just to generate the getters and setters. Okay, so this is my main method. I'll make it a Spring Boot application and I'll run it. Spring application dot run um, resilience 4J main dot class comma arguments. So we are set till here. I'll put sorry for that. I'll put a YML file for we'll need to write certain resilience 4J related configuration. So I'll get a YML file first of all. Now since I need to support the HTTP calls, I'll make one controller call. Let's say order controller. So say REST controller request mapping is slash order. Let's say string, we say order or place order, something of that sort, right? And let's see, we are getting an inventory as an input object. Inventory contains, let's say, name of a product and how many units that you want from that particular product, right? So I'll create a class inventory. So this I need a getter and setter. I need setter, I need getter. What else I need? I need product name. We are following almost a similar thing that we did in the plain Java lecture as well, right? I need the unit size. Okay, what is the product name, and how many units that you need to order. Let's say just a unit, how many units you want to order. Okay, so far so good. We come here, we have an inventory. Now from here we need to call um we need to call um, inventory service to check first whether the inventory is available or not, right? So I say I will make a REST call from here. Say REST controller. Okay, so I have a REST controller. I'll make a call to inventory service, not the REST controller, my bad. REST template. So I have the REST template, and I'll make a call to another service from here, right? I'll make a call from here. So uh, what all things that we need to pass? So we need to pass a request entity to the new service, right? So let's say new request entity. So in the request entity, what all things we need? We need a object that we need to pass. So we need an object, we need an HTTP method and the URI. So I say HTTP method get, and URI is, we'll put it. What is the response that we are expecting? Let's say I expect a Boolean response. Okay. So what happened? Request entity, response type. I think that should be okay. Why it is complaining? Oh, this has to be URI. Okay, so this should be, let's say, localhost colon 9090 slash, I say inventory, let's say inventory check. So this service we haven't created it, but we will do it, and this will return me back a response entity, right? Response entity of type Boolean. Okay, now we say if result, if it is true, as in the number of units are available for that particular product, then you place order, and I return, let's say, return order placed successfully. Okay, now this is your normal flow, right? What will happen if this particular method starts throwing an exception, as in you're not able to connect to another service? What will happen is it will throw exception right from here directly, right? So it's not very graceful handling. So what we'll do is we need to basically wrap around this particular method in a circuit breaker to make it fault tolerant. So how we can do that? We'll check that. Okay, so this is my get service. Here I say order check. I say check order first, right? This is not get, this has to be post, because we need a particular object into it. Now next thing that I need is I need to wrap it around circuit breaker. So circuit breaker have two things. First you need to give it a name, and then you need to give it a fallback method. Okay, so let's say inventory fallback, and the name for my circuit breaker is inventory break. Okay, so far so good. Okay, now the next thing that we need to do is we need to basically uh, configure the circuit breaker configuration for this particular one, right? Inventory break. So let's see how we can do that. So next thing is, this is my request body. I'll put, okay, we are pretty much set what we wanted to do. So let me go to my app. So I'll go to my application.yml, and here I say resilience for your circuit breaker instances. In instances is the name that we give for our circuit breaker. My name is inventory break. I'll go here and I need to configure it now. So let's say registry health indicator true, so that we should have information available on the actuator. Automatic transition, yes. um, I don't have any base config as any default configuration. My failure threshold rate is, let's say, 50%. Minimum number of calls, let's say 5 per minute. Number of calls in half open state, let's say 3. Sliding window size is 10. Sliding window type is, let's say, sorry, it is count based. Exactly the same thing that we did last time, right? So basically you have two types of circuit breaker windows. You have count based and the time based. uh, Count based is wherein I say my window for defining the circuit breaker outcome is, let's say, for 10 calls. So this is my sliding window size, right? So in a count based one, for these 10 calls, if my number of failures exceed 50%, which is like more than 5 calls are getting failed, then you open my circuit breaker, right? So this is what it is telling. And once it is open, it will move so it will move to an open state, and it will remain in open state for a time that is you are configured, right? So let's say how much time you need to wait it in open state, let's say 10 seconds. Now it will remain in open state for 10 seconds, and after that it will move to half open state. So once it moves to half open state, how long you want to keep it in half open state? Let's say uh, I say like 3 calls will be allowed in half open state. In out of those 3 calls, if my failure threshold remains less than 50%, then your circuit breaker will get closed and the normal flow will be resumed again. If it is again failure threshold is again more than 50%, then it again move to a open state. So this is what we are telling it till now. Okay. So let's go back. So this is our method. One thing we haven't done is we haven't created any fallback method yet. So define a fallback. Let's say my method name is check order fallback. Okay. So once we have our fallback method in place, let me put certain loggers into it so that we know uh, which method we are into. So I say inside fallback for product, I'll print my fallback product, say product name, right? Here I say inside check order for product. Okay, so we'll know where we are exactly. Okay, so I think we are done mostly. Oh, fallback method name is, we put inventory fallback, so let me change it. Okay, one more thing that it needs to be done is need to expect one more extra parameter. So that's how the resilience version works, right? It has to have exactly similar syntax. One with one more extra parameter, right? So in our case it will be inventory, and one extra parameter is your exception, which has been getting thrown when it invokes a fallback. So let me run the service and let's see if it is coming up or not. So it should by default be up onto port 8080. Till the time it comes up, let me open my Postman. And we till now we haven't yet created the other service, which is your inventory service. So once this comes up, we'll move on to creating the inventory service as well. Still initializing. Okay, it started it, right? So the service is up without any issue, so I'll keep it up for now. The next thing that we need to do is we need to create another Spring Boot project for a inventory service, right? That should be pretty simple. So let me create another project. I say inventory service, and what we need here, we need Spring Web, and apart from that I don't think so we need anything else. So I need a Spring Boot starter web, and I think that's it. Apart from that I don't need anything else in my project. Let me create a main method. So this is my main method, sorry, this is my main class. So I say inventory main, and it has to be a Spring Boot application. Public static void main Spring application dot run inventory main dot class comma arguments. Okay, so these are Spring application. I need to create one more controller into it to handle the request coming from your order service. This is my inventory controller. This is my REST controller. Request mapping. Say slash inventory, and what's the name that we give? We need inventory slash check. So we'll need inventory slash check. I'll go to inventory service. Here I say public boolean check inventory, right? This would be the get mapping. Say slash check, and I'll be getting an inventory from here. This should be a request body. If I'm getting request body, then it has to be post. Okay, I need to create a class called inventory the way we created in the order service as well. So here what I need, I'll just copy it from there itself. So we need product name and the unit. So we need created a product name and unit. I'll go here. Here I say get product name dot equals, let's say, soap, then return true, else if, let's say, fruits, let's say return false, don't have return false. Okay, so our service is in place. Let me run it on a different port. Say server, let's say 9090. I need to run it on, and I run my main class. Okay, let it couple of minutes for it to build. So meanwhile our postman is up. What we need to call a order service, order controller. So that is order slash check, and then inside that we need to give a inventory for it. Okay, order slash check. So this is unit, and what we say for it, other one, say product name, sorry, product name, let's say soap, right? Is it okay? Our service is coming up. It will give a couple of minutes for it to start completely, and then we'll check it. Okay, the service is up on port 9090. From order controller we are making call to 9090 only. Okay, so let me make a call and then see if it works or not. Sent a request at 200. Okay, however it directly goes into the fallback. So need to see why it goes into the fallback. It means it failed somewhere, and let's see why it failed. So now I go into my inventory service. There is no call came here. It is up on 9090. Let me see. I think we made some mistake. Inventory check. Okay, let me go back to here again. So this has to be a post method. Cannot be get, right? Now let me restart it again. This time it should work. But one thing which you have noticed is that even though this call failed, it directly got and go into the fallback method and it worked fine. So another thing that we should do is in the fallback I say product out of stock. So let me run it again now. Now, although we didn't this was not an intended failure, we saw the fallback, right? The fallback worked perfectly fine. Next thing that we need to see is when your circuit breaker trips and how you can find it out in Actuator, and at what, after how many failures it trips basically, right? So let's let it come up. Okay, come up, send it again. I got out of stock. Why it again failed? So let me call this method first directly and then see what is happening with that. Okay, it is not able to find the inventory check at all. So something has been going fishy there. I think the last code which was creating a problem, I guess. Okay, so let me go back again to order check, and let me do one more thing. I'll start capturing the failures as well so that I know what exactly is going wrong here, right? So I started printing my exceptions as well. Okay, service is up, and I should see the failure which has been happening, right? Let me check it now. I got failures back. I should see what exactly is causing an issue. I'm getting a null pointer exception. Okay, I can get a new REST template as well. Okay, so one of the things that I wanted to say is even though the service call is failing, it is perfectly executing your fallback, and it is giving a graceful result back to the user, even is the expense of services going down. So this is a classic example of how you can simulate um, the things when it goes wrong, and how you can basically get the results back. So here it's working perfectly fine now. Orders has been placed. So now I'll keep on executing it, keep on executing it. Now what we need to simulate is I will bring down my inventory service. Okay, so once it goes down, it should simulate a fallback, and we'll get a fallback, right? So at this point of time, even though service is down, see, you are getting an IO error. It is executing a fallback, and your user at the UI side is not aware of service has gone down. It executed a fallback, and you received the perfect response back, right? So this is simulating the exact scenario which may happen that we wanted to show. Now let it be down itself. What I need to do now is I wanted to show this particular thing onto the actuator. Okay, so next thing that we need to show is how we can see this particular information onto the circuit breaker, onto the actuator side. So what I've done here is I've enabled the circuit breaker first, circuit breaker information. So whatever resilience 4J fault tolerance strategy that you're using, you need to enable it first. So you have circuit breaker enabled, you have the bulkhead enabled, rate limiter enabled, and all those things, right? So as of now, I'm just doing it for circuit breaker. I asked actuator to enable the health endpoint and it show the details of that particular health endpoint. So I'll restart it for now, and then I should be able to see this information onto the UI side itself, onto the health endpoint. So I'll do http colon localhost 8080 actuator and health. Okay, so when I do that, what I'm getting is your circuit breaker is in a closed state as of now. Everything else is zero because we haven't made any calls as of yet. Okay, so let me start making the calls, and it will be failing because our inventory service has been down. Okay, so third failure, fourth failure, fifth failure, and now after this one, let's see at this point of time what is the state. It is in a half open state as of now. Failure again, failure again. Okay, let's make it again fast. The duration is quite small at 10 seconds, so let me do this thing. I'll give it is like 600 seconds, so let it remain there once it's open. Okay, let me run it again, let it come up, should reach now. And guys, till the time it comes up, right, put it in the comment, any more thing that you wanted to see as part of the circuit breaker pattern. uh, if you have any comments regarding my narration style, please put it in there. A lot of effort has been gone in creation of these videos and the series, so please go through it, subscribe to the channel. If you have any comments, please let me know. Your subscription, comments, and likes is the only motivation that the YouTubers like us get it when we see that someone is appreciating the effort which has been gone in, right? So please go ahead and subscribe to the channel. Let me make few calls. I think we have sufficient number of failures now. Okay, now you see your circuit has been opened completely. So it is basically expecting your three calls has been failed, right? And in that particular total time period. So failure rate is 100% for us now, because our window is of 10 calls and 100% of the calls are failing. So it's exceeded the failure threshold of 50%, and now the circuit will remain in the uh, open state, and after some time it will go into half open state. So right now from open it has gone to half open state, means now it will start accepting certain calls. And if I bring up my inventory service back up again, this circuit should get closed. Okay, so let it come up. We'll see that one as well. Okay, order place, order place, order placed. Circuit is closed, right? So normal operation has been resumed. So this is how you can do it. So this brings us to the end of this particular lecture on circuit breakers. Any comments, any suggestions, please go ahead and put a comment into the video. And the next lecture would be around bulkhead. So I'm going to create the entire series on this particular fault tolerance mechanisms. So in the next lecture, I'm going to cover the bulkhead, then the rate limiter, and then the retries. So please stay tuned and go through the entire series. And thanks once again for tuning in. Thank you so much.